Okay, so we have the PowerProbe EV tester with the leads shorted together on the milliohm 4-wire setting, which should be the most accurate. And you can see it's reading nowhere near 0. And we can 0 this, but I'd expect a milliohm tester to have this style clip, which is called a Kelvin clip, which is much more accurate and doesn't create as much resistance. Also, these leads have quite a bit of change to them when you move them around, which means these are picking up electrostatic charge in the air, and they're picking up noise and causing all sorts of issues. So I wouldn't recommend using this meter. Now the next thing I want to show you is even worse. You want to go ahead and flip those around for me? No, tops to tops. There you go. So you notice when we hook them top to top, we have an open. So the top parts of those jaws are not connected to anything. Okay, and this is it in 2-wire mode with the lead shorted together. We haven't zeroed it out yet, but we're at 280 milliohms with the leads just shorted together. And then if we wiggle and jiggle these, it's a lot more consistent in this mode, but I did get it to change a little bit moving them earlier, but now they're pretty steady. And now I'm going to show you just a set of standard high-quality test leads hooked to this, how this reads, just so you can see the difference. It's not a huge difference, but it's enough to help you understand why the quality of your leads really matter. This is connected, and you notice I have the part that moves connected to the part that moves, and we're at 0.25 ohms, and we haven't zeroed it, so that's just the offset of the resistance of our test leads. That gets you to change that, so we're looking at the two parts that don't move connect to each other. Yep, so the bottom and the bottom. Yep, go ahead and connect those. Yep, and oh, you had it. That's good. Actually, you're better the other way. So you can see here, let's try to connect that how you had it before, where they're kind of crossing a little bit. There you go, like that. So now you can see it's the bottom and the bottom, and we're at 0.25. So even just a good set of quality test leads really makes a difference. And then can you imagine having a big variance like that and then going down by 1 decimal point or 2 decimal points to get a better reading? You really need to have very high quality test leads and good compensation and accurate test methods in order to get there. And I wouldn't rely heavily on this tool in the milliohm settings. I wouldn't trust it.